Oh, hello guys. Have you ever looked at the label on your milk and thought, how do they know exactly 18% of calcium on your milk? Did someone just guess it? Or when scientists say there are approximately 3.5% of salt contains in the seawater, like, do they taste the whole ocean? Well, they didn't taste it. They measured it by using a special scientific methods, specifically gravimetric analysis. So, what is gravimetric analysis? Gravimetric analysis is a quantitative analytical technique that determines the amount of an analyte by precisely measuring its mass. One key principle is the analyte is selectively converted into a stable, pure and weightable compound. This transformation ensures that only the target substances contributes to the measured mass. So, the goal here is to achieve exceptionally high precision and accuracy in determining the composition of a sample, making it a foundational method in chemistry. Gravimetric analysis can be done in many ways, but we'll focus on just two common types that are easy to understand. The first is precipitation gravimetric analysis. This method involves turning the substance we're measuring into a solid by adding a chemical that makes it form a solid particle, or precipitate. We then filter, dry, and weight that solid to find out how much of the original substance was present. The second is volatilization gravimetric analysis. In this method, the substance is heated until it turns into a gas. We measure either how much gas is released or how much weight is lost to figure out the amount of the substance in the sample. Hello, today I'm going to do a little experiment. We're using gravimetric analysis principles to extract sea salt from the seawater. When the water evaporates, we'll be left with just the sea salt, and then we can finally weight it. So, without wasting any more time, let's get it started. First of all, we need to prepare the materials. We need a bowl of seawater, a kitchen scale, a small frying pan, and a spatula. Prepare the frying pan. Use low to medium heat. Don't leave it unattended. Now pour the seawater into the frying pan. Let it boil for a couple of minutes and occasionally stir. You can see the salt crystal is formed around the edge of the frying pan. Now all the water has been evaporated. You can see the salt residue from the seawater. Now we'll calibrate the kitchen scale. For the last part, scrape the salt into the bowl so it can be measured. Now we can determine the amount of salt in seawater.
Hi guys, alright, so you've seen how gravimetric analysis works. First, we prepared the sample, we precipitated the analyte, we filtered, dried and finally weighed it. But now, you might be wondering where is this method actually used. First, of course in chemistry labs like we did mention before, chemists use it to measure the amount of certain ions like sulfate, calcium or iron. For example, the calcium in milk or the iron in ore This can be measured using precipitation gravimetry, just like we did earlier. I'm gonna give you a little exposure of application of gravimetry analysis. First, we use it in industries and manufacturing. It used to make sure products meet quality standards. In the cement industry, they check the sulfate content. In the metal industry, they analyze ore purity. Even pharmaceutical factories use it to verify drug ingredients. The second application is in the food industry. Yep, it's even used to measure minerals or lactose in milk and cholesterol in cereals. So the nutrition labels we see often backed by the methods like this. In environmental testing, when checking water or soil pollution, scientists use gravimetric analysis to detect heavy metals like lead or iron, especially when accuracy really matters. And of course, in education and research like we are doing now, gravimetric analysis is also a great way to teach careful lab work, accuracy, and chemical understanding. So whether it's milk, medicine, matters, or environment, gravimetric analysis plays a big role in keeping things safe, accurate, and reliable. Everything in this world has its own pros and cons, so do with gravimetric analysis. Okay, so let's talk about the good stuff first, the pros. So the advantages of gravimetric analysis. First, accuracy. Like, if you do everything properly, gravimetric analysis can be very precise. No need to rely on fancy machines or expensive calibration. Just you, the balance, and your precipitate. Number 2, simplicity. I know it looks complicated with all the steps, but at its core, it just forms a solid, dry it, and weight it. No electricity, no problem. Number 3 is about cost effective. Once you got the basic lab equipment, that's it. No need for software licenses or maintenance fees. And finally, it's an absolute method. That means it doesn't need any reference or standard solutions to work. It's based purely on mass. So we are moving to the next topic.
Alright, let's dive into the disadvantage of gravimetric analysis. Number 1, it's incredibly time consuming. You have to wait for the precipitate to form, to filter it, wash it, dry it, and cool it, all of which can take hours or maybe even a days. So you might as well go cook for a dinner, watch a TV series, or maybe take a nap. Okay, alright, number 2. Gravimetric analysis usually only targets one element or compound at a time. So, if you are dealing with a complex mixture with multiple components, you need to run separate analysis for each one. There's a lot of glassware and patience. So, number 3 is demand precise, careful lab technique. Any contamination or incomplete precipitation or maybe error in weighing can completely ruin the result. One tiny mistake and all your hard work is waste. Also, gravimetric analysis easily can handle trace amount of analyte in large sample and they generate chemical waste you have to dispose of properly. So overall, gravimetric analysis is accurate, reliable, and relatively inexpensive, but it's definitely not quick or easy.
Alright, let's wrap this up. Today we learned that gravimetric analysis is basically all about measuring the mass of something after we've converted it into a solid form, usually a precipitate.
We walk through the process, prepare the sample, make it react, filter, dry, and sample inventory, but you gotta be precise.
Then, we look at the real-life applications from testing milk and cement to detecting pollutants and checking drug quality. Basically, gravimetric analysis shows up more than you think.
And of course, like everything else, it has its advantages and disadvantages. It's accurate, cheap, and doesn't need high-tech machines. but it also time-consuming and only works for one thing at a time.
In the end, gravimetric analysis is still one of the most reliable classical methods in analytical chemistry. And even though it's old school, it's still very relevant.
So, whether you are testing milk or metals, or just trying to pass your lab class, now you know how gravimetric analysis gets the job done.